if the moving averages themselves don't provide an advantage, how could anything built on top of them be advantageous? It just seems like extra complexity with an equally shitty foundation. All right. Welcome back to another episode with Sharp Education. It's been a while, and today I am not going to be continuing the machine learning progression we've been doing for a while. I want to build a little bit further into some of the studies we've already done. So my goal isn't to make you a professional quantitative trader. My goal is to give you a solid foundation as to how you should approach trading. And right now we already have a lot of really good resources for approaching trading effectively, smartly, and safely. But I want to show you how you can explore further the code bases and videos that I've already provided. And one of my favorite experiments that I've already done, and I'm going to be doing again today, is testing every single moving average combination. Now, we know how to break things into training and test splits, and we know how to make moving averages and every technical indicator that I deem to be relevant as well. So we can do a lot. But what I want to do is I want to see which moving average crossover combination is objectively the best across any time frame, any time period. And we can find that out using loops. Now, we know that no matter what we do here, we're going to be overfitting, especially if we are seeking the optimal moving average crossover combination over the look-back window that we come up with. But that's okay. We can have this conversation intelligently now. But this is just going to show you the process of optimizing efficiently. So some trading mentors, some bad ones, would say, like, this is the best moving average combination, or this is the only one that you need, or this is the only one that matters, or this is what I use to make $10,000 every day. Some stupid bullshit. Today, we're going to be finding out which one is objectively the best across any ticker on any time frame using loops. And so without further ado, I'm just going to get started with trading. So I've named this file moving average crossover 2 because we already have moving average crossover 1. We're going to take in some of the variables, so ticker and look back window, we'll keep those. But I like the data acquisition functions we got a little bit further down the line. They're more robust. So I'm going to take that from regression validation.ipynb, and I'm going to take the get data function here. I also need interval and everything. So this is what we're going to have for interval, period, and all of that. And the fast and slow, I'm going to define at the very bottom. Now, fast and slow, when we're looking at one moving average combination, they're just fixed numbers. So you can do fast 100, slow 200, and then calculate their turns using this series of functions. We'll paste this right in and then show you guys the whole output that we're working with originally, just as a reminder. So we load in our Yahoo Finance data. I think our look back window right now is 1,000. Yep. Then over the course of 1,000 days, we add our 100-day moving average and 200-day moving average. And you can see our returns relative to just buying and holding are worse. Interesting. And the trend, generally speaking, is they're always worse. But we want to find out if they are always worse. Is there one moving average crossover combination that actually did outperform over the course of these 1,000 days? And we're going to use loops to find this. So what if instead of just putting in one value, we put in a range of values, range between 3 and 100 for both the fast and slow moving averages? Well, we'll do slow to be a bit longer, 4 and 100. And I'll stick at the 10 just so the testing process doesn't take up too much space. So let's take a look at fast and slow. If we just define fast and slow as such, it's going to give us some errors because it looks like I'm going to do Control F and then fast. All right, so everywhere that's fast, I need to replace this to be a lowercase. Replace with fast. Replace all. Good. And same with slow. Replace with lowercase slow. Replace all. Now the global variables I'm going to keep here. fast, whoops, and slow. So that's a little trick for find and replace if you're using VS Code. I use it all the time. So what this should do, list of range 4 through 10. So we will want to loop through each of these numbers now and test programmatically all of these combinations. So that's going to be a lot of rows of data, but it's just how it's going to work out. So first we're going to loop through the slow moving average because that's the bigger number. So for S in slow, which is now a list of a range of numbers, we want to test all of the fast moving average combinations that are beneath it. So if we start our slow moving average at 4, we're going to test all of our fast moving averages that are less than that value. So at first we would just test 3. So now we could test 3 and 4 moving average crossover. And after that, that's all of the values that are less than our first slow value. Our next slow value is going to be 5. So we're going to test the 3 and 5 moving average crossover. And then we're going to test the 4 and 5 moving average crossover. Then slow is going to move to 6. And then we'll test 3, 4, and 5 crossing over with 6. So on and so forth all the way until we reach 10. So we'll do for S in slow and for F in fast. Instead of the capital global, we also need to make sure if F is less than S, then we can run this test. So data frame, fast, no, it's just F, and then S, S, F, F, and S. What happens when we run this whole thing? I'm getting a bunch of different plots. That's because I forgot to get rid of plt.figure. So let's get rid of this figure here and just move that down. Let's move plt.figure to here. And it also looks like it's trying to put two different things in the same. Yeah. So we don't need to plot the moving averages anymore. We don't need this. Get rid of it. Now, I also want the fig size to be a little bit bigger. So let's do figure equals, or fig size equals 12 by 8. That's a nice big one. And the title is not going to be the last combination we do. So what happens here? Awesome. So that legend is completely wrong. Let's take the legend out here. For now, we might add a legend back later. Whoops. Okay, so now we have the cumulative returns of every single moving average crossover combination between 3 and 10 for the slow moving average, and 3 and 10 for the fast moving average, and 4 and 10 for the slow moving average. Let me see if I can add a legend here. So I need to make a list of everything I'm getting. So let's do legend list equals here, just a regular list, and then legend list dot append, and it's going to be an F string every single time of the fast and slow crossover. So F S cross, and then at the end we'll do plt.legend legend list. Let's see how this works. Perfect. So there's a limited number of colors, but you can see that we have 1, 2, 3. I'm not going to count. We have a lot of combinations here. And the best one is one of the pink ones. Either 3 and 7, 4 and 9. It's either 3 and 7 or 4 and 9. So There we go. I was plotting the asset returns every single time, so it always looked funny next to the other ones because it was starting at however many. Like the reason the asset line or the S&P 500 daily line wasn't always the same is because we have to drop the number of rows it takes to calculate the moving average each time. So it would look different every single time, even though it would be a consistent color. Now this is a more correct chart. So the best plot here is green, and it's either 4 and 5 or 5 and 8. But from here, I want to know for sure which one was the best, first of all. So it's one of these green ones, and I could make the legend better, but instead I'm just going to do a scoring system. So once we have all of this sorted out, what we're going to do is add information to this function. Let's do a couple global variables within this main function. So we're going to do best returns and best params. So best returns is going to equal numpy.inf. It's just nothing. And best params are going to be the moving average lengths that we end up using. So for now, that's just going to be none. This sets it up to be a float, and I'm just going to leave this as is. You can basically see that as none if you want. It's the same concept. So for now, we want returns to be measured here. Returns are going to equal a float of the data frame asset returns or strategy returns, because we have that here, dot iloc -1. And if those returns are better, if returns are better than the best score, which is at the start none, then we're going to make best returns. Best returns is going to equal returns. Awesome. Now, we also want to get those parameters. So best params equals this list of F and S, fast and slow. Or I guess we want slow and fast, right? Yeah, S, F. Slow is going to be the bigger number. Okay, best params. And then we're going to set the title to be dynamic. So the optimal combination is going to be the best parameters that we get from running this study. And if I do everything correctly here, we should know which one is the best based on the title. 4 and 5 is the best combination that we've come up over 1,000 days of daily S&P 500 data. What if we did more? What if we did 10,000 days? What if we did all available data? Wow, not very good returns over the entire lifetime. But the best one is 7 and 8. So it looks like you don't really want to use moving averages. But what if we used exponential weighted moving averages? But again, we've only tested up till 3 and 10. We can do as many as we want. What if we move this all the way up to 100? It's going to take a much longer time, but I think we might find a combination that could work. All right. Now that's way better. Now we have every single combination between 3 and 100. But we could do as many as we want. We could do all the way to 1,000, but I don't have that patience. You can see that even all of these combinations took 1 minute and 14 seconds. Really interesting stuff. So even though we don't have a legend anymore, which it wouldn't really be useful because there's a limited amount of colors that humans can see, the optimal combination was 61 and 76. So let's go back to our moving average crossover combination, and let's put these in. Let's do fast 61 and slow 76. And we'll do the full look back window. We're getting daily data for the S&P 500, and just run it. So this is our 61 and 76 moving average. And despite that being the best one we could find, over a long period of time, it's just nothing next to buying and holding. Okay, a couple things before I go. I know that nobody is just doing a trading strategy based on moving averages alone. However, I think this is pretty indicative that there are no moving average strategies. A little bit sick. There is no space for moving averages in effective trading strategies. If none of them work, if no combination of moving averages yields any efficient results, or good results even remotely, then you shouldn't use them. They're not useful. But I'll take this a step further even. This is my claim. A lot of the other technical indicators we're using, the MACD, the Bollinger Bands, rolling relative strength index, and the money flow index, and there's a ton of other ones. They're all built on the principle of moving averages. They are extensions of it. Now, if moving averages themselves can never even come close to competing, why does anybody think that a technical indicator, regardless of what combination of them that you're using, why would that be enough to have you compete? If we can test programmatically every single combination and none of them come close to competing, how are you going to come up with one that outperforms if you don't even have the capacity to test it thoroughly? It's mind-blowing how separate the universes are between those who can test like this and those who think they know because of what they've been told. I learned trading through a book called New Trading for a Living, and it teaches you moving averages. It teaches you exponential weighted moving averages, which we can change really easily. All you need to do is, instead of dot rolling fast mean, you can do dot EWM. So now we're doing exponential weighted moving averages to see if there's any difference. And I'll even change this so it's exponential weighted moving averages, because some people like those better. I don't, because they are equally ineffective. More complicated, equally useless. All right, 62 and 92 are the best exponential weighted moving average combinations. We'll move this here. We have EWM set up. So we'll do 62 and 92 EWM, exponential weighted moving average. And just not even close. You're better off buying and holding. So again, we now have the ability to test every single combination of moving averages. Every single one. I encourage you to do even more. Go up to 1,000. I might even post 1,000 myself. But that's not going to be in the YouTube video because that's probably going to take about 20 minutes. But I might post it later on. And that's it. For me, this is pretty conclusive evidence that moving averages are completely useless. The technical indicators built on top of them are also useless. And everything you think you might know about trading and its simplicity is completely wrong. Super sorry to throw you on your head like that. But if you want to win in the space, I'm trying to show you you need to do something creative. This is a really good start, and I think it's an awesome extension of what we already have the ability to do. I hope you keep approaching my other videos and walkthroughs with creative extensions like this on your own. And I'm excited to hear what you guys think about my conclusions from this episode. If the moving averages themselves don't provide an advantage, how could anything built on top of them be advantageous? It just seems like extra complexity with an equally shitty foundation to me. I might be misunderstanding something, and if you think I'm missing something when I make that claim, let me know in the comments. But from what I've seen, and I've run a shit ton of tests, nothing built on top of retrospective price information is going to give you enough information to give you a sustainable edge in the long run. And you're going to need to find a way to do something more creative. We've touched on that with overfitting, breaking our data into training and test splits, and starting to dip our feet into machine learning, which in my opinion is the only way to actually do it. But I could be wrong. I just started a newsletter with all of the information I'm giving you right now and summaries of studies that I'm conducting like this. It's completely free, and I highly encourage you to sign up. It is all of my life's work and a sort of a hobby of mine to keep people informed around what's going on in the trading space, how you can approach trading more safely, effectively, smartly in general, and a couple other insights from the model that I built a couple years ago that has been outperforming the S&P for a long time now. Just yeah, sign up for the newsletter. If you like this content, I've got a lot more of it and even better stuff in there completely for free. Sign up on the website. Just go to the Slice is what it's called, and I'll send you emails every month with more studies like this that I'm conducting on my own that I don't have the time to make YouTube videos about. And I look forward to seeing you there. Thanks for being a follower and following along with my content. I apologize for the long break, but I'm going to start making more consistent content like this going forward. Hope you find it interesting. And until next time, stay sharp.